아무튼 뭐 아무튼 요렇게 하면 될 것 같아. 요거 보고 하면 될 것 같아요. Kafka Connect. Think 이 녀석이 참 뭐 해석 다 되지 않습니까? 영어 뭐 되잖아요. 예. Think Connector for Stream JSON 메시지 에서 스트림 제이슨 메시지에서 포스트그레스 SQL로 가야 하는 건가 봐. 그럼 제이슨이 아니면 안 되나? 한번 봐보자 또. 검색해봐야지 뭐. 싱크 커넥터. 이 아저씨도
My job is to make college easier because students have a lot on their
Sorry, Coach.
plates. Like Harper, an econ major who piles on the pressure. Grammarly can help her stress less.
This term paper's gotta be great. It's a third of my grade.
Your ideas are on the money. Let's make sure they come across clearly with Grammarly. Watch it work. Watch it work.
Wow, that is stronger.
And Avery, an engineering major who runs on ambition and coffee. Grammarly can get her her dream job.
My application needs to stand out. They only meet with the top candidates.
If you want to make a good impression and nail your delivery, use Grammarly. You don't want to pull another all-nighter, do you? Now that's taking it to the end zone. Yeah. Oh, touchdown with Grammarly. And Blake, an education major who knows what he wants. So you're going to be a school teacher.
Yeah, but first I need to...
뭐라고? 뭔가 남자. 씨, 팀즈가 다운로드가 안 됐네. 씨. 누구한테 메시지 보냈지? 아이고. 레브랭크? 아, 이번에 회사. 아무튼
Welcome to the video. In this video, let's see how comprehensive Kafka messages into the Postgres database. Let me open the terminal.
ETR. 아, 뭐 이분 배경음악 장난 아니네. 뭐 클럽이야? 해상도도. 지금 이 친구 같은 경우에 싱크 커넥터라고 하는 게 맞아. 에? 싱크 커넥터 싱크 커넥터라고 하는 거 이용해서 하는 거고. 아무튼 싱크 커넥터라는 거 이용하면 시작하자 이거지. 컨트롤 쉬프트 V. 아, 이런 것이.
안녕하세요. 새롭게 하소서 주영훈입니다.
안녕하세요. 연희엘입니다.
안녕하세요, 이정수입니다.
그 요즘들 그 투잡들 많이 뛰시잖아요.
네.
뭐 자격증도 있고 또 능력이 있어서도 있고 혹은 경제적인 어려움 때문에 투잡 뛰는 분들도 계시는데 우리 정수님도 사실은
잔일 버전. 거의 술 드시니까 그걸 하고 2월이 비수기예요, 대리업체가. 저는 손님이 계실 시.
좀 전에 소개 드리셨지만 목회 일도 하시면서 대리운전
강릉에서 왔습니다.
강릉에서
모셔볼게요.
어서 나오세요.
네.
어서 오십시오.
안녕하십니까.
감사합니다.
반갑습니다.
어서 오십시오. 어서 앉으시죠.
예, 예.
인상이 너무 좋으세요.
네.
영광입니다. 이게.
예, 감사합니다. 목사님 멀리서 오셨죠? 어디서 오셨죠?
강릉에서 왔습니다.
강릉에서 오셨습니다.
KTX 타고 왔습니다.
KTX 타고. 오늘 저기 뭐 같이 뭐
우리
이런
교우님들하고
교우님들하고 함께.
방송국 구경하는 게 쉬운 건 아니잖아요. 같이 오셔서 같이 왔습니다.
좀 전에 소개 드리셨지만 목회 일도 하시면서 대리운전도 하신다고요?
네, 그렇게 좀 하고 있습니다.
그럼 대리운전 하신 지 얼마나 되셨어요?
벌써 7년이 됐네요. 공부방이네, 벌써 7년 됐네요.
그럼 주로 몇 시부터 몇 시 정도
이제
일을
밥
하세요?
먹을 때, 그러니까 7시쯤 나가서
예.
시간을 물어보시자면은 손님이 계실 시까지.
굉장히 늦은 시간일 수도 있잖아요.
3시에서 4시까지도 할 때도 있어요.
그 연말은 또 굉장히 또
요즘에는 이제 그 연초 1월하고 2월이 비수기예요, 대리업체가. 그러니까 작심삼일 버전. 거의 술 드시니까 그거를 좀 해보자 해서 1, 2월은 좀 비수기고.
그 연말에 많이 들으시죠?
그렇죠. 연말에는 정신없이 바빠요.
아유, 근데 이게 이렇게 바쁘시다 보면
네.
사실 목사님 일보다 대리운전 일이 더 많으실 것 같은 그런 느낌.
그렇죠. 아무래도 그러니까 시간 안배를 잘 해야 됩니다. 시간 안배를 잘 하지 못하면 어쨌든 제 본업은 목사니까
예.
그 영성을 안 놓치면서
오, CTF 같은 거. 아무튼 first class. 한번 영상을 좀 보자. 영상을 좀 보겠습니다. 13분짜리 영상인데 여기서 좀 힌트를 좀 얻자. 네. 컴플런트 야도 컴플런트 쓰잖아. 야도 컴플런트 쓰네요. 아, 참말로 돈 내고 쓰는 거 아니야? 돈 내고 쓰는 거잖아. 아, 안녕하세요, 무서운 개발자예요. 아무도 안 봐. 아, 이거 돈 내고 쓰는 게. 야도 컴플런트 쓰잖아. 야도 컴플런트 쓰네요. 아, 참.
안드로이드 앱 개발 종결합니다.
아, 뭐야. 돈 내고 쓰는 거잖아. 아, 참말로. 돈 내고 쓰는 거잖아. 자, 안녕하세요, 무서운 개발자예요. 뭐냐면 아무도 안 봐. 아, 이거 돈 내고 쓰는 거.
안드로이드 앱 개발 종결합니다.
에이씨. 돈 내고 쓰나? 컴플런트. 컴플런트. 5.1점. 컴플런트. 진짜 돈 내야 하나? 검색해야지 또.
Let's start. It's okay.
여보세요?
So basically, I use a converter and offset part is defined and plugin comes into that the Java JDBC Java is of Postgres database is saved. And let's see the properties of Postgres database. Here is the database parameters. Let's change the topic of this and table name we have created a table class student. Let's change the table name students. The name is just name of this property file. Change the students. We have the table name and the class. Let's start this one. And basically we need to download any JDBC file for Postgres as Kafa holds the Postgres and SQLite just by default. Standalone command is started. Now let's run the consumer so that we can see if the message is sent to the producer is properly received by the topic. Now let's start the producer sends messages. And I have also defined the schema within the producer schema properties, which is an arrow format. Arrow is nothing but the extended version of JSON, and the messages sent should also be in the arrow format. Basically, here we are using just the JSON. These messages successfully received by the topic. We can see the messages printed in the consumer. Let's check the database. Yes, the message is properly inserted into the table. Let's send out the message. And I've also property of the console producer. I'll just copy the file. Put it here. Yes, this message is also successfully received by the topic and the database as well. Now let's create a file with a set of data and let's send the file to the producer and let's watch the behavior. This is basically JSON form. We can also constrain the data set, but right now I'm just inserting the file to the table using the same schema we have created for the producer. Let's save the file. So using the same property, let's pass the file along with the file. Yes, the message is successfully received by the topic as we see printed in the console. Yes, the data is successfully loaded into the table. Thank you guys. Please continue to use the replays and subscribe to the channel. Today I'm going to show you some of the ways that you can use the Kafka Collect JDBC sync to put data into a database from Kafka and some of the little tips and tricks with it. So I've got an environment here, I'll put it on the demo scene repository, and if I do Docker compose, yes, you can see we've got some different containers, we've got our broker, we've got Kafka Connect. We're going to use KCDB just as a front end to put data in, so let's get going. So to start off with, I'm going to use our cheat sheets over here. Again, this is on the demo scene repository, and we're going to KCDB. So KCDB just lets us interface with Kafka, create topics, populate topics, and so on. The data that I'm putting into the JDBC sync, or through the JDBC sync into the database can come from any topic that you've got, although there are some caveats around the format that it needs to be in, and we'll talk about that later on. But to start off with, we're going to create ourselves a nice simple topic. We're going to create stream, that's 01. It's got a schema, it's got a couple of columns to it. We're going to put it into a topic called test 01, which is our case, and we use Avro. So Avro is really important because Avro gives us one way of managing the schemas. So with the JDBC sync, one of the massive things is you have to have an explicit schema for your data. So you have to either use Avro or you have to use JSON but with a schema embedded following a certain pattern. We've got like the schema and the payload segment, and I'll show you that later on. But Avro or JSON with a schema, you can't just chuck CSV in, you can't just chuck JSON in without an explicit schema. So we use Avro because it makes our life nice and easy. Let's put some data into the topic. So again, KCDB, we can insert into the stream. Insert a couple of rows into the stream, and if I say show topics, we've got a topic called test 01, and test 01 print, test 01 from beginning. We're just going to dump out the content of the topic now, and it says here's your topic. Got the timestamp, and we've got a key, and we've got the values. So we've populated the key by specifying row key as one of the fields when we're populating the stream. So we set the message key, and
더 논리정연하게 말을 했으면 좋겠다 싶은 분이면 바로 이 수업을 들으셔야 되는 거예요.
Yeah, so I'll be giving this presentation about data pipelines with Postgres and Kafka. I gave the same presentation earlier a month ago in PGCon EU, but this time around it was actually supposed to be presented by my colleague, but apparently he fell sick earlier today, so I'm covering for him. So the agenda for the actual talk is I'm going to be talking about the data pipelines, some bits about Kafka and how does it work, and the related concepts, then how do you use Kafka and Postgres together, a word about influx somewhere in between, and then how do you use Kafka for data processing of the data. The data examples I'm mostly going to be covering are actually from real-life events about time series data and their manipulation. Word about me, I'm a co-founder at Ivan. I'm also a Postgres aficionado, have been using Postgres for ages, and have contributed to multiple different open source projects around it. Yeah, so a word about us. We're a database as a service startup. The producers write stuff to, let's say, this logs topic. What happens is that they just write to it. There's nobody reading at this point. But let's say we come up with all this data, and they're actually processing a real-time profile of you. What are you itself? So if you actually want to balance the load, a paper for compression. It compresses time series data really efficiently, but it's also, because the compression is really efficient, it's also, this footprint is really small. It's also fairly fast, and it scales fairly well. Unfortunately, it doesn't have things like HA. It used to have a rudimentary way of doing. These scales are transferable to Cassandra, not that many, because things could support things like Amazon S3 if you want to put the data into object store. They could be things where you push data into Postgres. That is a fairly common way. Also in real time. So let's say you have a service where you have hundreds of HTTP web servers that are getting error.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to.
Today I'm going to show you some of the ways you can use the Kafka Connect JDBC sync to put data into a database from Kafka, and some of the little tips and tricks with it. So I've got an environment here. I'll put it on the demo scene repository, and if I do docker compose PS, we can see we've got some different containers. We've got our broker, we've got Kafka Connect. We're going to use KSQLDB just as a front end for putting data in. So let's get going. So to start off with, I'm going to use my cheat sheet over here. Again, this is on the demo scene repository. And we're going to KSQLDB. So KSQLDB just lets us interface with Kafka, create topics, populate topics, and so on. The data that I'm putting into the JDBC sync, or through the JDBC sync into a database, can come from any topic you've got. Although there are some caveats around the format that's in the and we'll talk about that later on. Let's start off with, we're just going to create ourselves a nice simple topic. I'm going to say create stream test01. It's got a schema, it's got a couple of columns to it. We're going to put it into a topic called test01, which is lowercase. I'm going to use Avro. So Avro is really important because Avro gives us one way of managing the schemas. So with the JDBC sync, one of the massive things is you have to have an explicit schema. There you can insert into key and then my SQL system. What we're going to do now is, here, create ourselves another screen, and we're going to create our connector. So I could actually create this connector in KSQLDB itself. Here I'm just using the REST interface of Kafka Connect Direct. Clipboard. And then I'm going to go into the container itself, Docker exec, into the Kafka Connect container. I'm going to run bash, get into that. I'm going to change into that folder. Change directly into that folder. Within that folder, we have to have the jar for the JDBC driver. Don't put it anywhere else. Don't go put it somewhere else and change your class path or change your plugin path or all of that kind of monkeying around that you'll see on the internet.
방송 마이크를 껐었구나. 브레인 네트워크, 데이터 파이프라인 구축하기, 실행, 아파치, 로빈, 실시간 스트리밍, 파이프라인 실수, 데이터 파이프라인 데모, 데이터 인그레이션 using Kafka Connect. 서비스 urban 플랫폼 2번. 반대로 가네. 어우, 어우 뜨거. Sync Connector. Confluent. Runtime. 아씨 보기 싫어. 아우 보기 싫어. 아우 무서워. 안녕하세요 무서운 개발자예요. 안녕하십니까 무서운 개발자입니다. 여러가지 이유로 무섭죠. 아 보기 싫어 씨. Skimmer. How should you do? 한글로 번역해야지. 스키마 없는 제이슨 객체를 인덱스가 있는 저장할 수 있다는 것을 발견했습니다. 싱크 커넥터. 동영상. Best Kafka Connector. Run. Maven. Setup local 주기풀 서비스. Setup local Kafka service running. Setup local RabbitMQ service running. jar find int directory. jar package JDBC sync get as a source code which you can easily build the jar file. Is Kafka connect sync connect for copying data from into JDBC database. 오케이. 복사해. Property and JDBC sync file into local etc Kafka. Go to Kafka installation directory. Set class path value to as following. Configure create car target Kafka topic name. Kafka test. 주기풀 set up JDBC database with the accessible URL and port number as well as number and user with the read-write privilege. Involve in creating a database, creating user and password, and below command involved setting Postgres to user. Below some of the command involved in setting up database using DB2, using a Docker image. Below are some of the command involved in setting up database using DB2 using Docker image. Create DB2. Docker runs through port. Docker logger for my DB2. DB Kafka test connect to Kafka test. Tables. Teach2 JCC jar file from the following. DB2 using below some command in DB2 using a Docker image. Involved the setting up database. For using file using the command below. JDBC connect to JSON. Table name. Password. Standalone model. Command to start to sync connect to service. Start to sync connect service in standalone model. Property, sync, property, distributed model. Sync connect. Kafka test. In order to learn the connector in distributed model, you must first register connector with Kafka Connect service by creating JSON file, format below, name format, company, user, password, DB full size, true. JSON data. Localhost connector, producer, copy, Kafka test, following record into the first terminal, string optimize, field name, name, General Motors, timestamp. 라이센스 뭐 이렇게 하면 되는 거야? 뭐야 씨. CSV잖아. Place record into the producer terminal. 이렇게 하면 되는데 요거를 하면은 해준다는데 근데 지금 이게 뭐냐면 지금 이게 그냥 제이슨이야 제이슨. 제이슨이야 그냥. 배열 나와 있고 필드 네임 준비 스키머 type structure person, payload. Payload, name, company. Field, name, person. payload. 아씨 힘드네. 요거 말고 딴 데 가봐. IBM 말고 2번 source connect The connector has three insertion mode. 3개의 인섹션 모드가 있네. 3개의 인섹션 모드가 있어. 어? 아무도 안 봐. 인서트 모드, 멀티 모드, 업데이트 모드가 있어. 업데이트, offset 모드, 데이터, db2, postgres, primary key, no primary key. record value, auto evolution, db2. 엄마 동사무소. Small example. We have a message server. 학원. column name, type. We have a message in JSON that looks like this. JSON이 하나? JSON으로 하나? JSON, payload, hello, field, convert, schema. record value into field parser publish into message topic. Here is a configuration that make this case work. JSON converter, convert, connect class, connection URL 5432 topic message Format should be published into message typing. 뭐야, 씨. How to correctly 이렇게 하면 되는 거야? 모델 싱크 커넥터. 응?
내가 까먹을까?
아니 안 까먹었는데.
어?
안 까먹었어.
그거 맞춰봐.
왜?
그거 사격.
어?
사격 1등. 그거.
사격 1등.
그거 뭐 준다고 했잖아.
뭐 준다고 했지?
지구 우주.
아 맞아 맞아. 사줄게. 걱정하지 마. 사줄게.
아빠 근데 이 약은 뭐야?
아빠 감기야. 기침 계속 나서. Sync Connect Config Option RST URL Connection URL Apache Kafka 제이슨이잖아. example Confluent Community 망고? 어디 있는데? 아, 싱글 머리 아파. 머리 아파. Soft bracket. Single bracket. Yeah. Get started. 싱글 브로커에 대해서는 공짜였네. 에? 카프카. 다운로드 컨플런트는 싱글 브로커에 대해서. 싱글 브로커에 대해서는 공짜였습니다. 공짜였어요. 예? 안녕하세요, 무서운개발자. 싱글 브로커. 그러니까 하나의 브로커에 대해서는 싱글 무료는 이었군요. 이런 식. 그러면 우리가 뭐 브로커가 많이 있을 거나 하잖아. Sign up for Confluent Cloud and start streaming in minutes. 씨알을 일단 뭐 공짜도 있으니까. 아무튼 나도 있지만 이번 싱크 아프라치 카프카를 이용해서 good configuration data type mapping documentation. It has a Postgres support. 뭐 다 있어. 근데 이게 뭔가 제이슨 형태로 뭔가 이렇게 만들어줘야 되네. 그러면 제이슨으로 컨버팅을 해야 하나? CSV를 아무튼 뭐 originate from the code was blocked before change of the project license. We wanted to thanks Confluent team for their effort developing the connector and aim to continue keeping the fork well maintenance and truly open. Apache Kafka compatible database. 아무튼 요거 받아가지고 아 진짜 아무튼 뭐 DB에 자동으로 집어넣으려면 direct URL might look like connect allow you to transfer data topic into the relation option reference value must be structured with the primitive field. 뭐 중요한 말은 must 기본 필드가 있는 구조체여야 한다. 구조체여야만 한대. 카프카 connect IBM 거 봐볼까? 아무튼 이 친구 아주 되게 친절하게 잘 되어 있어. 받아오고 MVN으로 빌드를 하래. 메이븐. 그리고 주기퍼를 셋업하고 카프카 셋업하고 서비스 레비랭크는 왜 하지? Confine jar 파일을 그 옮기래. 카프카 타피. 에? 주기퍼. 셋업 JDBC 데이터베이스를 URL 포트넘 as well as usual 하래. 스탠더런 모드 분산된다. Kafka produce block list. 한번 들어가 보자. terminal console producer will wait for output 이렇게 하래. 아씨 이렇게 해야 하네. 이렇게 해야만 들어가. CSV를 그러면 로그 스태시 로그 filter. Output protocol, my data. Hopefully this is right price. Fairly new. Jason Palmer wanted to company into upload consuming. I was wondering, import 뭐 키도 집어넣어주고 separate data output 뭔가 방법이 있나 보네. 방법이 있어. 레고 스태시 input generator type CSV filter mutate parallel payment date payment original date value payment value code output Ruby debug codec JSON the output message payment rename date payment date payment original recast okay column codec JSON으로 바꿀 수가 있네. 아무튼 JSON으로 바꾸고 JSON으로 바꾸고 나서 바뀐 들어온 녀석을 그러면 해보자. 아무튼 되는 거 확인한다. 되는 걸 먼저 보자. 자 그러면 sync connector 이분 거 다시 보자. 왜 그러냐면 왜 그러냐면 이게 브로커 하나에 대해서는 공짜잖아. 이거 다시 볼 필요가 있지. 왜냐면 매뉴얼이 없어. 따라서 할 만한 게. 자, 이 아저씨 주기포 실행하는 거야. 카프카가 설치되어 있는 데서 주기포라는 주기포 실행하는 거야. 주기포 실행하는 거야. 여기 이제 주기포 실행하는 거예요, 여러분. 할렐루야. 아무튼 뭐 주기법 이미 근데 다 실행되어 있잖아. 일단 넘어갈까? 다 실행되고 됐잖아. 이렇게 실력이 없어서 어떻게 하냐. 주기법 실행시키고 카프카 실행시키고 자씨 다운로드 받아. 유튜브 다운로드. 윈도우즈 비디오 플레이. VLC 다운로드. VLC 다운로드. VLC 아무튼 요거가 여기 뭐냐 가부점에 주기법 실행하는 거야. 주기법 서버 스타트. 주기법 서버 스타트. 주기법 서버 스타트. 주기법 주기법 서버를 시작한다. 자, 두 번째 카프카를 실행시킨다. 카프카 서버 스타트. 카프카 서버 시작해. 카프카 서버 시작하고.
Kafka server is started. Now both Zookeeper and Kafka server is started successfully. Let's create a table in Postgres database. subject.
subject.
Character vary
3자 문자.
executive type as character vary. Let's see. Length would be 30. Percentage. Let's say decimal.
이렇게 해서 테이블 만들고 포스트 그래스 테이블을 만든다.
Table is created. Let's create a topic. Type of topics. Create. Zookeeper. Localhost. And port number. Replication factor. Let's say 1. Partitions. Let's have one partition. Topic. And let's name it as springs. Topic is created.
카프카 토픽을 만든다.
Let's then check the topic. Yes, the topic student is created successfully.
확인한다. 카프카
Yes, the topic student is created successfully. Now let's start schema registry. Schema registry basically will register the schema provided at the Kafka producer schema property. Schema registry basically will register the schema provided at the Kafka producer.
스키마를 등록한다.
User schema property. Now let's start the standalone connect in order to insert the data into Postgres database, which holds the database credentials. This is the standalone properties file, which has bootstrap servers, and it has the converter properties in which the data is consumed, So basically we have used arrow converter, and offset path is defined, and plugging path is defined where the jar file, JDBC jar files of Postgres database is saved. And let's see the sync properties of Postgres database. And here we have the database credentials. Let's change the property name to students, and table name we have created the table name as students. Let's change the table name to students. The name is just name of the same property file. We can change it to students. We have the JDBC connector class. Let's start with Connect. And basically we don't need to download any JDBC.
여보 나 6시 40분에 좀 깨워줘.
응.
뭐? 뭐? 그거 하는 거야. 그거 빨리 해. 2학년 거 문제 좀 넘어가지. 이 양손 시험 대신에 하는 거잖아. 이제 없으니까 시험지 다 했으니까.
Arrow converter. This is the standalone properties file which has bootstrap servers, and it has the converter properties in which the data is consumed. So basically we have used arrow converter, and offset path is defined, and plugin path is defined where the jar file, JDBC jar files of Postgres database is saved. And let's see the sync properties of Postgres database. And here we can define the database credentials. Let's change the topic name to students, and table name we have created the table name as students. Let's change the table. And basically we don't need to download any JDBC jar file for Postgres, as Kafka holds the Postgres and SQLite jars by default. Standalone connector started. Standalone connector started. Now let's run the consumer so that we can see if the messages sent through the producer is properly received by the topic. Okay, consumer is started. Now let's start the producer and send some messages. Okay, consumer is started. Now let's start the producer and send some messages. And I have also defined the schema within the producer schema properties, which is an Avro format. Avro is nothing but the extended version of JSON, and the messages sent should also be in the Avro format. Basically, here we are using just the JSON. The schema within the producer schema properties, which is an Avro format. Avro is nothing but the extended version of JSON, and the messages sent should also be in the Avro format.
뭐나? 뭐나? 뭐냐 말이다.
Basically here we are using just the JSON. Yes, message is successfully received by the topic. We can see the message is printed in the consumer. Let's check the database.
안 돼, 아빠 이래야 돼. 없어지는 게 아니야. 비누야. 물로 손으로 닦아봐.
아니 비누 물이 안 나와.
그럼 거품 나올걸?
아니 아빠도 한번 해봐. 야, 안 나와. 뭐? 어떻게 묻혀지?
야, 여기 비누 물 나와 이게. 왜 안 나와?
진짜야.
아유. 물로 닦어요.
봐봐, 없죠 진짜. 아, 물 안 묻은 손은 그냥 이렇게 봐. 이렇게. 봐봐. 자.
Yes, the message is properly inserted into the table. Let's send one more message. And above is the property of the console producer. I've just noted that file.
물 안 넣어. 거품 안 생겨? 거품 안 생겨?
Yes, the second message is also successfully received by the topic.
Really?
And the database as well. Now let's create a file with a set of data and let's send that file to the producer and let's watch the behavior. This is basically a JSON form.
안 돼. 교회 가서 뭐 먹으면. 우리 당분간 뭐 먹으면 안 돼.
We can also stream the data set. But right now I'm just inserting the file into the table.
마스크 벗으면 안 돼. 교회 가서.
They have created for the producer.
아직 우리 안 돼.
Okay, let's save the file.
자기가 여기다 사탕 갖다 놨어? 고마워요.
So using the same property, let's pass the file name along with the file.
야, 여기다 하면 어떡해.
Yes, the message is successfully received by the topic as we see printed in the console. Yes, the data is successfully console. Yes, the message is successfully received by the topic as we see printed in the console. Yes, the message is same property. Let's pass the file name along with the path. Yes, the message is successfully received by the topic as we see printed in the console. Yes, the data is successfully loaded into the table. Thank you guys. Please comment in case you have any queries and subscribe to the channel.
가정.
지금 낼게. 아니야 이따가 내 지금 엄마 돈 계산 못했어. 지훈아, 차 놓치지 말고 얼른 가.
어이씨. 아.
엄마가 제일 잘할 거야. 우리가 와? 어? 아 진짜? 뜨지 마라. 나 보기만 할 거야. 갈게 엄마. 아빠 드디어 클라이맥스 왔어.
좋은 거야?
완전 좋네.
이야, 씨. 알았어, 아빠 영상 찍어줄게.
와 드디어 클라이맥스. 70회. 와 이거 완전 좋은 건데. 아빠 클라이맥스가 이게 지금 아빠 엄마가 이걸 2개나 샀어.
음.
우와.
좋겠네.
와 진짜 좋아. 우와 다 하고 이 클라이맥스 사진 찍어놓게. 아빠 여기에서 영격도 나온다. 아빠 여기에서 영격도 나오고
진짜?
얘도 나오고 얘도 나오고 피카츄도 나오고 얘도 나와. 아빠 얘도 나오고 그다음 얘 이렇게 나와.
진짜?
우와 진짜 좋아. 여태까지 클라이맥스 때부터 안 했어. 아빠
어?
나 샤인스타 사주라. 나 생일날에.
진짜?
샤인스타 사주라.
샤이니스타? 그게 뭐야?
좋은 것만 나오는 이렇지. 샤인스타 이거랑 진짜 그거 아니, 이것보다 그 클라이맥스가 그거 내가 말한 게 제일 비싸. 와 25주년 여태까지 안 뜯었으면 이거 같이 해가지고 뜯을 수 있었는데. 와 좋다 형. 아빠. 여기서 제일 좋은 게 뭔지 알아?
몰라.
얘랑 봐.
응. 어.
봐봐. 얘랑
어.
봐봐.
어.
얘랑
어, 진짜?
진짜 클라이맥스 2개는 한 개는 그거는 이해는 녀석 생일 선물로 줄 거거든.
진짜?
이 녀석 생일이 내가 생일날에 뭐 포켓몬 카드 좋은 거
응.
카드 준다고 했었어.
이게 얼마나 좋은 건지 알아?
모르지.
나 지금 가격이 이게 얼마고 지금 찾아봐요. 여기서 잘하면 1호치고 구할 수도 있어. 네. 우와.
야씨.
아빠, 이게
어.
내가
어.
막은 게 왜 좋은 거냐면 이게
어.
봐봐. 얘는
응.
얘네 다는
응.
얘네들은
어.
이렇게 반짝 거리지가 않잖아.
응.
얘는 반짝거려.
아, 그래?
이게 더 좋아. 그래서 클라이맥스랑
어.
그다음에 뭐지? 그거 연격 아닌데?
어.
그거 뭐지? 뭐 어쨌든 1호치 나오는 거 있는데 그게 제일 좋아. 그거랑 얘가 제일 좋았지. 유튜버에서 이게 나오는 건데 지금 이거 사려고 장독대가 지금 당근마켓까지 그거까지 했었어.
진짜?
그거 사려고 지금 그 가격이 진짜 비싸가지고. 아빠 당근마켓에 완전 좋은 거 클라이맥스 이거 12,000원에 판다.
진짜?
이거 아예 안 뜯었어. 이거
진짜?
아직까지.
진짜야?
그거 사면은 지금 이거를 이렇게 연결해서 뜯을 수 있어. 한 개는 형거 한 개는 내 거로 이렇게 반으로 갈라가지고 이렇게 쓸 수 있지 클라이맥스.
진짜야?
응.
와.
아 이모티콘 사이? 아 티콘이 아니구나.
아니야, 선물해 주려고 그래.
누구? 아빠? 누구?
아빠 친구 생일이어가지고.
진짜?
어. 아빠 자냐.
기프트 카드 줘.
기프트 카드?
응.
진짜?
기프트 카드가 얼마나 현질이.
뭐 10만 원짜리를 줘서 가지고 자식.
근데 연필 어디 있더라?
어?
드디어 클라이맥스가 왔어.
롯데 마트.
회원카드 중에서 제일 좋은 게 25주년이랑 제일 1등급이 여기에서 뭔지 알아? 맞춰봐.
몰라.
1등급. 얘야. 봐봐. 아빠. 얘.
어?
얘랑 얘야.
아,
그다음에
그래?
샤이니스타.
그렇구나.
그게 제1이야. 1위. 그게.
그렇구나.
이게 그 샤이니스타가 좋나 25주년이 좋나 이렇게 비교해보면 클라이맥스랑 이렇게 비교하면은 이게 몇 년 전 거냐면 25주년이 이게 모르겠다 어쨌든 이게 클라이맥스 VMAX 지금 VMAX가 여기에서 많이 나온다는 말이야. 아빠 여기서 금손이면은 하이퍼레가 무조건 또 하이퍼. 누구냐면 얘나 봐봐 얘나 봐봐 봐봐 얘나 이렇게 뜰 수 있어.
진짜?
잘하면은.
그렇구나.
완전 좋은 게 많이 나온단 말이야. 우리가 여태까지 뽑고 싶었던 게. 이게 10팩밖에 없는데 이게 무거워. 봐봐. 10팩이 없는데
이렇게
10팩밖에 없는데
그래?
봐봐.
10개밖에 없는데 왜 이렇게 비싸?
10팩
으이씨, 왜 이렇게 비싸?
10배. 봐봐, 무거워, 이게. 심지어.
왜 이렇게 비싸?
이게 왜 비싸냐면, 좋은 게 많이 나올게.
진짜? 알겠어.
25주년도 좋은 게 알잖아. 좋은 이유가. 그래서 좋아서 이게.
할렐루야.
그래서
생일.
내 생일날에 90점 맞는 날에 이걸 받은 거지. 우리가 그때 샤이니스타를 몰랐었던 거야. 샤이니스타를.
진짜야?
당근마켓 찾아봐, 샤이니스타.
진짜 싸?
봐봐. 이게 우리가 지금 포켓몬 카드 박스를 몇 개 샀냐면 한거랑 내가 합하면 4개 산 거야.
왜 이렇게 많이 샀어?
우리가 박스.
돈 모아서 이제 돈 아껴야지. 언제 필요할지 모르는 건데 그런 거 이따 써도 되는 거야?
쓸 때가 있지.
쓸 때가 있어?
지금 왜쓸 때가 있냐면
응.
포켓몬 카드를 팔려면 돈을 받잖아.
아 진짜야?
카드 결제는 또 안 돼. 무게도 카드 결제는 안 돼. 돈 결제는 돼.
진짜?
이게 아빠 이거 어떻게 하라는 거야? 아빠? 이거 맞아 이렇게 한? 봐봐. 아빠? 얘는 더하기고 얘는 빼기? 맞아? 얘 더하기 얘 더하기 빼기 빼기 더하기 더하기 빼기 빼기 더하기 맞아?
엘리베이터가 내려가는 거야. 13에서 빼야지. 더하기. 그렇지.
25주년은 차이가 다른 거야. 지금 여기 25주년은 좋게 따르는
니들 니들
25주년이랑 다른 이유가 있어요.
치킨.
교회 가서 봐야지.
그래야.
여기 없구나. 아빠 이제 클라이맥스에서는 유니온이 나와. 그리고 아빠 이거 후회 안 하는 게 좋아. 클라이맥스에서 유니온이 날 확률이 낮아. 크지 그게. 얘도 큰데 내가 한번 뽑았어. 내가 이걸
진짜?
내가 한 번에 유니온을 뽑았어. 그래서 다 깜짝 놀랐지. 내가 근데 한 번은 다 보니까
응?
아빠, 그래서 이거 어떻게 사는지 알아 지금?
몰라.
아니 엄마 이걸 어떻게 사는지 알아?
몰라.
이게 지금
진짜?
그래가지고 지금은 이거 엄마가 싸게 샀었고요.
그래? 싸게 샀어?
이게
진짜?
아빠 봐봐 얘는 차이가 다르잖아. 봐봐.
그러네.
차이가 달라 얘는 이렇게 돼 있고.
거라거나.
얘는 글씨도 이렇게.
치킨.
아 치킨 쿠폰 줬어?
어.
부럽다. 세 살이면 이거 안 된대. 봐봐. 3살 이후면 안 돼. 봐봐. 맞지 아빠? 세 살 때는 안 돼? 무조건 나이가 있어야지 돼. 우리는 강하고 초. 얘는 아빠 봐봐. 이렇게 봐봐.
응?
이렇게 다르잖아. 얘는 점점점 이렇게 돼 있는 게 열 때 하는 공간이 되는 위에 있고. 봐봐. 아빠?
응.
자세히 보면은 얘는 여기 있잖아. 좀 뽕뽕뽕.
그렇구나.
여기 다른 데가 얘는 높이 있어. 25주년은. 25주년은 18팩밖에 없던 게 아니 16팩밖에 없거든. 그럼 13으로 나눌 수 있다는 거지.
뭐라? 아무튼 도쿄 캠퍼스 앱 마이너스 대 캠퍼스 페스 쿠버네티스 쉐라이 다이그램 캠퍼스 Kafka topic from sorting your data. Generate mock data. 이거 복잡해. 앞쪽 풀어볼까? 앞쪽 풀면 뭐가 있나 볼까? 세 번째. 알아? 뭐 이렇게 많아? 자르 파일. 세븐 준비 없어가지고 다운받고. 안녕하십니까. 안녕하십니까. 안녕하세요. 무한도전 개발자 입니다. 뭐가 있나 봐봅시다. 카프카 덤플라 윈도우즈 배치 파일들이 있고 etc 센터 각종 자료 파일들이 있고 아까 config share 자바 카프카 커넥트 JDBC share 자바 카프카 커넥트 위시 없네. MQTT share 자바 카프카 커넥트 약간 틀리네. 찾아볼까? 스키마 레지스트리. 프로필 다운로드. 왜 안 돼? 왜 안 나오지? 그럴까? 어씨. 어? 왜?
이걸 모르겠어.
어떤 거?
이거.
어떤 거? 이거 사다리타 하면서 계산하여 빈 곳에 알맞은 수를 써 넣으세요. 사다리타 일로 가지고 이렇게 하면 6을 더하면
아니야, 이렇게야.
아니야 이렇게야.
아닌데?
아니야 이렇게야. 진짜야.
이렇게 하는데?
사다리는 위에서부터 내려오는 거야. 그래야지 여기 빈 곳에 채우지. 11에서 6을 더하고
아빠,
6을 더해서 7을 빼.
봐봐.
응.
얘가 여기로 가 있으면
응.
아니지.
어?
얘가 여기로 가 있어야지. 더.
아하. 그럼 여기서부터 해봐. 이렇게. 아니야 여기 있어도 이 친구를 플러스 6을 하라는 거야. 11에다가 플러스 6을 하라는 거야. 그것도 플러스 6을 하라는 거야. 왜 싫어? 야 그렇게 하는 거야. 감사합니다. 아빠가 모르는 거라니? 어. 어.
얘가 땅이지,
어?
봐봐, 얘가 땅이잖아.
어.
얘가 땅이면 여기서부터 이렇게 가야지.
아니야. 사다리는 이렇게 내려오는 거야. 진짜로. 진짜 여기서 11에서 6 더하고 마이너스 7 빼고. 그렇지. 자, 12에서 5 빼고 6 더하면 진짜 엄마한테 가서 물어봐. 진짜야. 진짜라니까. 그렇게 한번 해봐. 하고 싶은 대로 한번 해봐. Using Docker image, you can install entire component platform individual component. Image are available, and the source file for the image are available on the GitHub. You can extend and rebuild an image and upload them to your Docker repository. Docker image reference of information about the component platform image. Node environment. Multi-node environment. Persistent data. Mounted volume. Mounting Docker external volume system used for their processed data. Host networking. Kafka connect image. Adding connector to the Kafka connect image. Supported Java. Untested feature. Swarm. Demo. Problem. Compose. Uninstall Docker system program. Reinstall or guide operating system currently supported by current platform. YAML. Compose. To run detach mode. Detach mode? 야, 이거 뭐 하는 거야? Detach mode? No, detach mode. 뭐 하는 걸까? 이제 한걸 번역해. 시작된다. 출력은 담가왔다. 드디어 실행 중인지 확인한다. 이렇게 하면 실행을 하고 있다. 몇 번의 구성 요소가 상태가 업이 아닌 경우 명령을 다시 실행하거나 Restart image name Control Center 주제 만들기 토픽 주제는 이제 토픽이에요. GS Center 지하 센터로 이동하고 로드 되는데 1분 걸리고 브로커 하나 있고 주제를 클릭하여 주제 목록을 연다. 클릭하여 주제 작성을 시작한다. 페이지 뷰 사용자 주제 만들기 유저 주제를 만든다. 모의 데이터를 생성한다. 커넥터를 추가한다. 커넥터를 생성해. 컨버트 키 변환기 클래스 add connector verify topic page view converter source connector의 두 번째인데 소스 커넥터는 그냥 가져오는 거잖아. 어디에서 가져올지. 휴지 스키마 검사 스키마 K SQL 스트림 및 테이블 만들기 뭐하는 걸까 씨. 힘들어. 이렇게 길어 씨. 힘들어. 힘들어. platform. Demo reading material. Enriching stream, enriching with jab, with jab, with jab, with jab, with jab. 아이씨, 진짜 어려워. Private Kafka. 아, 어려워. 힘들어. 씨. 아멘. 아, 힘들어. 씨. 클라우드 example. 퀵 스타트는 어디 있어? 플랫폼. mock data. Create a topic to start your data stream on your data. Query and join stream. Build a view. Docker. Platform. Or in one Docker compose file. Docker compose up -D to run detached mode. You offered schema broker 주기fer DB CLI KSQL KSQL은 뭐야? What is KSQL? Kafka stream engine for Apache Kafka SQL engine streaming SQL for Apache Kafka is database anyone with SQL knowledge to process any data coming into any chosen topic with Streaming engine for Apache Kafka makes it possible to build the streaming process application as SQL using familiar SQL interface. Voila! Is your client library for building application and microservice where the input and output data stored in the Kafka cluster. You can use perform steam process task using SQL's Bitdynamic. Create a topic, create a real-time stream. Okay. Image. Kubernetes. Kubernetes config. Confluent. Confluent Kubernetes.
Hi, I'm Tim Berglund with Confluent. Today I want to talk to you about running Confluent on Kubernetes. Confluent for Kubernetes is a declarative API-based control plane used to deploy and manage Confluent on any self-hosted Kubernetes-based infrastructure. You can use it to manage Confluent platform components like, say, schema registry, connectors, or Kafka itself, as well as application resources like schemas, connectors, and topics. We build off the standard Kubernetes APIs for managing networking, storage, and compute, and as a result, we can operate on any CNCF-conformant Kubernetes distro. We'll start with the Confluent for Kubernetes operator. This plays the role of the management control plane. The operator is packaged and installed as a Helm chart. Let's provision it. For each type of Confluent component, like Connect, KCPB, Kafka, all the gang,
뭐지? 왜 소리가 안 날까?
changed custom resource. The operator will notice what you've done and do something about it. To illustrate this, let's provision a production Confluent deployment. Let's start with a scenario guide for a production deployment. I'll look at these scenario examples here in GitHub. Now, what do we care about when we're configuring for production? We want a deployment that includes authentication, Confluent RBAC authorization, and full network encryption. And that seems like a reasonable place to start. We want it to be properly sized, of course, so let's specify the RAM and CPU to give to the Kafka brokers.
Memory, CPU, Kafka.
And I'd said that we want network encryption, right? Well, for implementing that, we'll bring our own certificates. This requires that we specify a certificate authority and server certificates generated by that certificate authority. We'll provide these certificates as a Kubernetes secret, and Confluent for Kubernetes Kubernetes will take those and configure security for each component. It's so great. Now, to deploy Confluent, we'll just take the file with each component's custom resource definition that specifies production sizing and security requirements and apply it. And there you go. You have a complete Confluent platform deployment with appropriate resources and security all configured from one declarative spec. Now that we've got our deployment,
오이씨, 가만 안 돼. 소리를 안 내시면 Kubernetes, Nginx, my Kafka client, Zookeeper, my Kafka headless Zookeeper, service headless, none, cluster IP.
deployment, what do we want to do next? Well, obviously a dashboard view. For that, we turn to Control Center. Now, since this cluster is secured with Confluent RBAC, we'll need to specify a user for Control Center with the right role and permissions to monitor this Confluent deployment. We can specify all the permissions needed declaratively through role bindings. Once that's in place, we use the Confluent kubectl plugin to open up the Control Center dashboard and log in. Confluent provides an ecosystem of connectors to move data into and out of your Kafka deployment. This ecosystem is available on Confluent Hub. I'm going to choose the DataGen connector to work with here. This connector produces automatically generated fake data of a variety of schemas, which is really useful in testing scenarios like this one. It's super cool, honestly. The connector configurations are expressed in the connector custom resource. This connector requires a topic to produce data to, which is not surprising. We'll call that ratings and define it through a Kafka topic custom resource. The topic has a schema, and that's also defined declaratively through the schema custom resource. We'll provision the connector by applying the YAML definition file. What just happened here is that Confluent for Kubernetes reached out to Confluent Hub, pulled the DataGen connector from the hub, installed it and deployed it along with the required topic and connector, and all with just one deploy command. Now, if you think about it, this infrastructure definition is sort of like code. We might even say that this is infrastructure as code, to coin a phrase, and this approach, this infrastructure as code approach, unlocks another possible set of practices broadly called GitOps, where the state of your infrastructure is defined in a GitHub branch, and changes to that infrastructure can be negotiated and ratified by pull requests. Suppose you want to scale up the cluster we just deployed. We'll create a pull request where we update one thing, change the number of Kafka brokers from 5 to 7. Once this pull request is merged, the GitOps continuous deployment pipeline will apply the Kafka custom resource, provisioning new storage, memory, CPU, networking resources, or whatever you want on worker nodes, spinning up new Kafka brokers, ensuring that they're running and existing partitions are balanced across all those brokers. All of this is automated in Confluent for Kubernetes with one declarative spec change. Now, suppose we want to develop and test a new app. We'll want another Confluent deployment, a development environment. So let's deploy one. We'll have custom resources for all components of Confluent Platform, just sized for a development use case. That's just the memory, CPU, and storage we need at minimal cost. And remember how we talked about network encryption? Well, here we choose the second option. We'll use auto-generated certificates. We'll provide a certificate authority, and Confluent for Kubernetes will generate and configure certificates for each component. Again, it's such a relief to have that done for you. We're using a Minikube Kubernetes cluster as our development infrastructure, typical laptop-based kind of thing. We'll apply the dev YAML for a single node cluster to Minikube, and we're up and running. Now that we have my development environment set up, the next step is deploying the streaming app that we're building. We can explore to see what Kafka listeners are in place. For each listener, we can get the client configurations we'll need. It's all provided in the Kafka custom resource status. We'll add this client configuration to the new application. Here, we've got an application that produces random quotes from movies. I kind of like it. The application, just like everything else, is expressed as YAML files. Once deployed, we'll log into Control Center and inspect that my app is functioning, and it looks like it is. We got movie quotes flowing into our topic. With Confluent for Kubernetes, you can define the entire state of your infrastructure and applications using the declarative constructs you expect from Kubernetes. This allows you to automate and manage your streaming infrastructure and applications from one cluster to hundreds of clusters across your organization.
My job is to make college easier because students have a lot on their
Sorry, Coach.
plates. Like Harper, an econ major who piles on the pressure. Grammarly can help her stress less.
This term paper's gotta be great. It's a third of my grade.
Your ideas are on the money. Let's make sure they come across clearly with Grammarly. Watch it work. Watch it work.
Wow, that is stronger.
And Avery, an engineering major who runs on ambition and coffee. Grammarly can get her her dream job.
My application needs to stand out. They only meet with the top candidates.
If you want to make a good impression and nail your delivery, use Grammarly. You don't want to pull another all-nighter, do you? Now that's taking it to the end zone. Yeah. Oh, touchdown with Grammarly. And Blake, an education major who knows what he wants. So you're going to be a school teacher.
Yeah, but first I need to get my senior thesis over the finish line. I keep repeating the same words.
Let Grammarly help you find the right words faster. Grammarly, do your magic. And you did it in one place. Grammarly means better results. That's why it's the writing tool selected by 3,000 schools and universities. Try Grammarly for free by clicking the blue button. Class dismissed. Go on, download Grammarly today. Blue button. Right there, Grammarly. Oh yeah, click it. Don't look at us. It's just a coach and a duck. It's all right, you click that blue button. All right, you've seen it before, haven't you? Ooh, Grammarly, for the win.
유튜브 프리미엄에서는 휴대폰 화면을 꺼도 영상이 멈추지 않아요. 백그라운드 재생으로 끊김없이 들으세요. 무료 체험하세요.
Hi, my name's Robert Moffat. I'm a developer advocate at Confluent, and this is From Zero to Hero with Kafka Connect. Kafka Connect itself is part of Apache Kafka. It's the integration API for Apache Kafka. And it lets you build streaming integrations from systems upstream into Kafka topics, and from Kafka topics to systems downstream. So it means you can integrate all of these systems with their data flowing into Kafka and out of Kafka. The great thing about Kafka Connect is it's just configuration files to use. So you set up a lump of JSON and you say, I want to use this particular connector and I want to get the data from this particular place and stream it into this particular topic. There's different uses for Kafka Connect, but if you think about the applications and the pipelines that you build with Kafka, anytime you're doing integration with another system, you should probably be reaching for Kafka Connect as your first option. So some people use Kafka Connect for building out streaming data pipelines. Perhaps, as we can see here, streaming data from maybe a transactional database through Kafka and onto somewhere else to do analytics. So we want to offload that data from our transactional system, go and put it somewhere else where we're going to do our big crunching, our ad hoc analytics, our machine learning. By streaming it through Kafka, we benefit from Kafka providing the back pressure and the integration capabilities. We could add in additional databases to this pipeline, and we nicely loosely couple our consumers of the data from the producers of the data. Since Kafka stores data, we can use that same data that we've ingested from the database once, and we can write it out to other places. So we can take it to S3 in the cloud, and we can have it on premises on HDFS, but wherever we want to have that data, it's only coming from the source system once. We could also use Kafka Connect to help us with our applications, where we're writing data into Kafka from an application, and we'd like to get that data onto somewhere else. Perhaps we want to stream the data to a NoSQL store, or we want to write it somewhere else for audit purposes or for analytics purposes. Instead of our application having to take on responsibility for connecting to that target system and handling things like scaling and network problems and all the rest of it, our application just writes its data to Kafka, and then we hook up Kafka Connect, and that manages getting that data reliably from Kafka to that target system. Another pattern in which we see Kafka Connect being used is helping us evolve existing applications towards newer ways of doing them. So a lot of the time our existing applications are built with databases holding the state. So it's an existing in-house application or a third-party application, and whatever it does, it probably ends up writing stuff to a database. When it writes to a database, those are events, and we can capture those events and we can use them to drive new applications. We can say, in this CRM system that exists somewhere else, when someone writes a record, we would like to write a new application that responds to the fact that a new record has been created, or the record's been updated or even deleted, and we can capture those through Kafka Connect into Kafka and use it to drive applications. Those are some of the uses for Kafka Connect, some of the patterns in which we see it being used. So now let me actually show you in action and give you that kind of idea of how it's to use and what it's like to actually build things with it. So there's a repository called Demo Scene. This is where we put a lot of the demos that you see us presenting, and we've got one down here called From Zero to Hero with Kafka Connect. And within this you've got a Docker Compose file, so all you need locally is Docker and Docker Compose. You can say Docker Compose up, and then you can actually follow the full script through. So I'm going to be looking at this one here, and you'll see me kind of like moving between my screens and where I'm focusing, because I'm going to take the commands from there. We're going to use that to build out this demo. And so you can see I've started the stack up already, and we've checked that Kafka Connect's available. The next thing we're going to do is we're going to check that our particular connectors that we want to use have been installed. So we go to that, and we're saying to Kafka Connect. So Kafka Connect uses a REST API. So you use it to configure it and to find out about the state, and we can use it also to find out which connectors we've got installed at the moment. After I've shown you Kafka Connect in action, I'm going to talk about how Kafka Connect actually works internally so that we understand enough as end users how we actually go about using it. I'm also going to talk about running it and kind of how we go about deploying it. So when I talk about installing connectors and stuff like that, we'll come on to that later, don't worry. So we can see we've got different connectors installed, which means that we can now actually crack on with getting some data into Kafka from our source system. So what we're going to build is an integration between a relational database streaming its data into Kafka, and then we're going to take that data and we're going to stream it out to two different sinks. We're going to stream it to Elasticsearch and to Neo4j. So our relational database is MySQL, so let's launch a MySQL prompt, and you can see that's started up there. And if we say show tables, we can see you've got a table called orders. So let's have a look at that order data, And you can see within that table, you've got information about an order that's being placed. So you can see the ID of the order, we can see the value of it, what was the order for, who placed the order, when was it created, when was it updated. So I'm going to set a little data generator running. I'm just going to create a separate window here and set that running. And if I go back to MySQL now, and if I query it again and say, just show me the latest record, you can see you've got new data arriving in it. So order ID 509, order ID 519, 521. So these orders are being created all of the time and just arriving continually in this relational database. So that represents our existing application somewhere in our business, somewhere in a third party. We're going to stream data from that database into Kafka. And I'm using a database, but it could be a message queue, it could be a flat file, it could be anywhere that we want to integrate with. We're going to stream that into Kafka using Kafka Connect. So let's see on here, let's come out of MySQL. I'm going to set this running, which simply polls MySQL every second or so, and it shows us the latest record, because we can compare this to the data as it's arriving into Kafka once we've set that up. So now we'll go and create the connector. So this is the actual integration piece. This is the configuration. So it looks like this. It's quite a long bit of JSON because it's a fairly, there's lots of different things that we need to set up within it. But basically we're saying we would like to use from the Debezium project, the MySQL connector. We're going to say here is where MySQL is, here's how we connect to it, here's the particular table that we want to get data from, this orders table, and a couple of transformations, which I'll talk about later, but how we're going to process that data as it passes through. So we can see here we've sent that to the REST API and it says we've created it. And now we can say, well, let's have a look at the status of that particular connector. And it says the connector here, it says it's running. Okay, so the connector's running, which means we should have data flowing in to our Kafka topic. So now we can go and do this. We can actually have a look at that data. So I'm going to run a consumer here using a tool called KafkaCat, and it's going to go to our orders topic, and it's going to show us from the data that's flowing in. Well, let me show you the raw payload to start with, and then we can actually see what else is happening. So each message that's come from the database, we can now see in the Kafka topic. We've got the order ID, we've got the customer ID, we've got the order total, and so on. So that's flowing into the Kafka topic. That's as anything changes in the database, it's going to flow straight through into the Kafka topic. Let's go back to our previous screen where we could see the output from MySQL, so the latest data as it's arriving. And I'm going to split that screen there. I'm going to do it like this, vertically. And we're going to run that same command. And this time we're going to say to the Kafka consumer, just show me the ID, the create timestamp. So we're just going to see those two fields so we can actually track as this data arrives, it's actually in sync with what's happening in the database. So if we look on the left-hand side here, we've got the database ID 834, 836, and if you look over in the Kafka topic on the right-hand side, there's 834, there's 836. So as the data gets changed in the database, it gets reflected in the Kafka topic straight away. Now, let's take that data and let's stream it somewhere else. So we've got the data flowing in from a database into a Kafka topic, and now we can push it from a Kafka topic down to somewhere else. So let's send it over to Elasticsearch. So again, we're using the REST API of Kafka Connect. We're creating a new configuration, this time with the Elasticsearch sync connector. We're taking data from this particular topic and sending it over to Elasticsearch. We say we've set that up, it says it's been created. We're also going to send the data over to Neo4j. And you'll notice for each of the different connectors we're creating, there's some standard configuration, like here is the connector class, here is the Kafka topic. And then you have configuration specific to the connector. So where is Elasticsearch? What do we want to do with the schemas and the keys? And depending on where the data is coming from and where it's going to, you'll have different configuration that you need to specify. So when we set up the configuration for Neo4j sync, again, it's the Neo4j sync connector. There's our standard connector class. But Neo4j needs to understand how it models this data. And Neo4j's got a language called Cypher, and so we express using Cypher how to model that data that's coming through from the source. And so we go and create that, and then we say let's have a look at the status of these three. And we can see here that we've got the Elasticsearch one is running. The Neo4j one has failed, which is terrible because this is a live demo or a recorded live demo. So we're going to go and check out Elasticsearch, and then we're going to go and poke around and see if we can understand what's up with the Neo4j one. So let's have a look at Elasticsearch. I'm actually going to use a tool called Kibana on top of that. So here's Kibana. We're just going to refresh some of the fields, and then we can open up Kibana. Let's open that in a window there and put that on the screen over here so that you can see it. And within this, we've got the data as it flows in to that topic. So let me put the window like that so that you can see what's going on here. And close that down and put this window down here. And now we can see we've got data flowing into the database here, order ID 118. We can see the same data flowing into our Kafka topic on the right hand side of that pane there. And then here at the top of the screen is Kibana, which is sitting on top of the data in Elasticsearch. It's set to refresh every second or so. And as that data arrives, here's our order ID 1142, 1149. That's as the data is arriving in the database, bottom left of the page, flowing into a Kafka topic, bottom right of the page, and then over into Elasticsearch and being rendered in this dashboard within Elasticsearch at the top of the page. Neo4j, we'll figure that out later. If we get time, we'll actually fire up a bit of a debug session. But for now, I want to go back and explain more about how Kafka Connect works internally. Now, Kafka Connect is part of Apache Kafka. So part of Apache Kafka, there is an open API. You can go and look at the Java docs. You can look at the Kafka improvement proposals, the kit, the design documents behind it all, which as developers of plugins, as like coding this kind of stuff, that's super interesting and super relevant. As users of Kafka Connect, as developers, as data engineers, we only need to understand some of it. We don't need to dig all the way down into it for deliberate reasons, which is Kafka Connect abstracts this concept of integration for us and it exposes a configuration interface. We don't need to understand all of that, kind of like the bits and bytes all the way down there. If we want to do that, we'd go and write some separate code. But the whole point of Kafka Connect is you don't need to write that code. You just use the configuration. But you do need to understand what's happening in the pipeline that we're building. So the first piece of the puzzle is the Connetor plugin. Now this is the piece that speaks the specific technology with our source or target. So if we're pulling in data from a database, it speaks like JDBC, or it goes to the MySQL bin log. It speaks the actual API that's necessary to get the data in from that source system or write it down to the target system. We specify it using the connector class, and when you install the connector, the documentation will tell you the name of the connector to use. That connector is the only bit that's specific to that source or target technology. So if we're using a connector reading data from a message queue, it's going to speak the particular API for that message queue, but it passes internally within Kafka Connect a representation of that data. It passes the actual payload, the value of it, and the schema of that data. But it doesn't have anything more specific to do with that source system anymore. It's now just a generic representation of that data. Taking that data and writing it into Kafka is the job of the next plugin. And this is the Converter plugin. So when we write data to Kafka, it's written as just bytes. We just write bytes to Kafka topics. Kafka is not opinionated about how we serialize that data. I am opinionated about how you serialize that data. You should be opinionated about how you serialize that data, because there are good ways to do it and there are less good ways to do it. When we take that data from a source system, it has a schema. Almost all the time, it has a schema. We just sometimes choose to ignore that fact because it makes things a bit more complicated. But they're complicated for a good reason, which is when we're building applications, when we're building pipelines, schemas act as our API, as our contract between the different pieces of the puzzle. So if we chuck them away, it makes life so much more difficult and it makes the processes that we build much more brittle. So use something like Avro, use protobuf, use JSON schema, use something where we have a schema for that data because it makes things so much better in the long run. With the schema for the data, it gets stored in the schema registry, and then Kafka Connect or any other tool that's writing to Kafka will write the message itself onto the Kafka topic. If we're using Avro, if we're using protobuf, it's a nice small little binary representation of that data with a schema available separately. And since the schema is available separately, it means that any consumer of that data, whether it's Kafka Connect as shown here, or your own consuming application that you're writing, or something like KSQLDB, it can fetch that schema from the schema registry, it can deserialize the data, And then, so if we're writing the data down to a database, because we've got the schema, we can go and build that table automatically from that connector. We don't have to go and do it manually and find out the schema manually because we have it already from the schema registry. So the converters are a very, very important part of it. It's really worth your time understanding exactly what they are, what they do, and how to use them properly. You specify them as a global configuration in the Kafka Connect worker, and I'll explain workers later on. You specify, I would like to serialize the value for my message using this converter. I would like to serialize the key for the message using this converter. And also, when you're deserializing it, which converter do you want to use? Now, obviously, you want to make sure that you match these up. You can't serialize it using one method and deserialize it using another, because that just would not work. So if you're writing Avro onto the value of the message, you need to read Avro from the value of the message. And if you don't, you hit the kind of errors which we'll talk about briefly later on. Now, in previous versions of Apache Kafka, there was a configuration called the internal converters, which was exposed. And this caused lots and lots of confusion and wailing and gnashing of teeth, because people sometimes run into trouble with converters, and so they say, right, I've got a value converter. And then I can see there's also an internal value converter. And things aren't quite working, so I'm going to add in another one. I saw this thing on Stack Overflow, or I Googled something, and I found this blog that said I should also have a key internal value converter, and then a key internal value converter, and then things still aren't working, so I'm going to add in more and more of these things, and please just hope that something will work with these converters. Now, since Apache Kafka 2. something, it was quite a while ago now, those internal connector configurations have been deprecated, and you just specify your value converter and your key converter. The third piece of the little box of plugins that we have are single message transformations, and these are optional. When you're building a Kafka Connect pipeline, you need to specify your connector plugin, where's the data coming from or going to, the converter, how are we serializing or deserializing that data with a Kafka topic. Transformations give us a really nice ability to apply transformations, the clues in the name, to the data as it passes through the pipeline. So as we're taking data in from a source system, we could say, well, drop these particular fields. We don't want to write those to the Kafka topic. As we're reading data from a Kafka topic, writing it down to a target system, you could say, I would like to change this data type here. I would like to add in this piece of data lineage. So transformations, they're part of the configuration of a connector that you create. They're not the most straightforward things to set up, but the syntax looks like this. We say we've got the transforms prefix, so that's the transformations, and then for each one we give them a label. So we say it's going to have a date, it's going to have a label foobar. Now label foobar is a silly label to give because it tells us nothing about what it's going to do, but we've got two transformations with two different labels. Then we say for each transformation, so we've got transforms dot label as the prefix, and then each one's got a type, and then other configuration elements. So here we've got a timestamp router, which is saying take the topic name and append the timestamp with a year and month on it. And we've got one called label foobar, which if we look at it carefully is actually saying rename delivery address to shipping address. So we've got these three different plugins that we use in building out our pipelines. It's all extensible. You can write your own if you want to. So connector plugins, there's a huge ecosystem of them out there from the community, from vendors. So a lot of the time they exist already. But if you've got some new technology for which one doesn't exist, go and write it. If you're writing your own plugin, don't start mucking around with thinking my plugin must handle like I'm going to write to the Kafka topic, because you don't do that. Your connector plugin just takes the data from the source system and passes it on internally within Kafka Connect. The converter is responsible for serializing that data. So if you've got a different serialization method, you can go and write your own converter. And transformations as well. People quite often end up writing these for particular purposes. So you can get all of these off Confluent Hub. So go to Confluent Hub, type in a particular technology that you're interested in or transformation that you're interested in. So you want to transform data that's coming in as XML, you type in XML, you search for that on Confluent Hub, and you find there's a single message transformation that will do that for you. So that's enough of what you need to know about what's happening within the Kafka Connect box to be able to set it up as a developer, to build some pipelines and integrations with it. But then you need to run it. Then you need to actually set these things going and manage it and operate it. You could just use Confluent Cloud, where we have managed connectors, so then you just configure it and it gets run for you. But if you're running Kafka Connect on premises yourself, then you need to understand a bit how are we going to actually go and deploy that? What's the runtime look like? So we have some more terminology. We've talked about connectors and converters and plugins. Now let's talk about connectors and tasks. When we run a connector in Kafka Connect, we have this idea of a logical connector. So we've got like a sink writing data from a Kafka topic to Amazon S3, for example. That gets carried out internally with the actual runtime by a task. And you could have a different connector, you could have a JDBC source pulling in data from a database, and again we have a task that runs this. But Kafka Connect can also parallelize work within a given connector. So we might find that the JDBC connector says, actually, I'm going to run 2 tasks because you asked me to pull in data from 2 tables, and I'll pull both tables in parallel. So that's this down to the author of the connector plugin, who will say, well, I'm going to enable it to scale out if the user has allowed me to, and I'm going to do all of this work in parallel. Depending on the integration that you're doing it in parallel might not make sense. You might want to force it to be serial, so that can be configured. These different tasks are actually executed within a worker. So we're now down to the actual nitty-gritty of the JVM, of the process that we're going to run to actually run Kafka Connect. When you go to the command line and say, run Kafka Connect for me, please, you're actually instantiating a Kafka Connect worker. This is the JVM process that you'll see if you go and look at what's running on the box. It's called a worker. Within the worker, the actual tasks and stuff like that get executed. There are 2 different deployment models for Kafka Connect workers. There's one called standalone, and there's one called distributed. Now it's worth understanding this carefully because you may not choose the one that you might guess is the appropriate one. Standalone is not usually what I would recommend you use, even if you have a single node standalone that you want to run it on. And this is why. The standalone worker is not fault tolerant at all. If it dies, you lose your stuff. You have to kind of like revert to a backup or something like that. It's not scalable. So if you want to add in additional capacity, you have to set up a separate worker and you have to partition your connectors across them. So in this example here, we've got the JDBC source connector. It's got 2 tasks running within it. If you need to scale that ingest, you can't because you have one worker running one connector. That's as low down as you can go. Whereas if we run a distributed worker, the distributed worker can run on a single node. So it's like it doesn't have to be distributed to actually run the distributed worker. We have a single node running all of our tasks. But it uses Kafka itself to store its configuration and progress and stuff like that, which means that if we add in a second worker, it can find out the configuration and so on from Kafka, and it scales out beautifully. So we can now have tasks running across 1 or more different workers. Kafka Connect allocates that work accordingly. If we lose a worker, Kafka Connect will say, okay, we've lost something here, we need to move that work around to make sure that all of that work's being carried out. So we can scale it out as much as we want to, both for redundancy and throughput. And if you go from a single node to another node, you just add in an additional worker. Whereas if you're using standalone, and then you say, oh, I need a second worker, or I want to switch from standalone to distributed, it's a different way of configuring it, it's a different way of running it. It's just easier, generally, to start with a distributed worker on one node, and then if you need to scale out, if you don't, well, that's fine, because it's just as easy to work with on a single node. You don't just have to build one great big cluster of Kafka Connect workers. You can, and some people do, but you will also see organizations who will partition their clusters of distributed workers. So you may have one cluster of workers that's like resilient and fault tolerant and scalable, handling one set of connectors or one business unit's work, and then a separate one running a bunch of other stuff. So it's up to you how you deploy that. And that could be running against a single Kafka cluster or different Kafka clusters. You can carve it up entirely how you want to. You run Kafka Connect as a JVM process. So you can run it on bare metal, you can also run it on containers. So there's a base image that's provided. If you go along to Docker Hub, you can find that on there. And then to install your particular connector plugin that you want, you need to install that into the container when it's actually run. Otherwise, you just have the runtime. The important thing about installing these connector plugins and converters and transformations as well, if you're using them, is that they need to be installed before the worker runs. You can't install them afterwards, which means that we need to think about how we're actually going to do this. So you use Confluent Hub usually to pull down the particular jar file for the connector or the plugin or whatever that you need. And then we can do it one of two ways. We can either say at runtime, we're going to instantiate this base image, and then before we launch the worker process, we're going to put in a little bit of code to say we'll pull down the additional plugins that we want and then launch the worker process. Or we can actually go and build our own image, which is probably the more kind of proper way of doing it, but it adds in additional steps if you're actually just doing this as like a prototype thing on your laptop. So you'll see all the demos and stuff like that we publish on Demo Scene. A lot of the time we use this pattern because it's just like, here's the base image, edit the Docker Compose YAML to add in a few more things, and then off we go. But if we were doing this thing for real in production, you'd probably end up building your own images. You can also automate creating the connectors themselves because you create connectors by using the REST API. So you can actually put that into your Docker Compose also, or into however you're deploying your containers. Now, I mentioned we talk a little bit about troubleshooting as well, because we've seen what Kafka connects for. We've seen how to go about configuring it and understanding it from an end user point of view. We've seen about understanding it from an operations and runtime point of view. But now let's think about it like, well, what happens when things go wrong? Because things do go wrong, let's be realistic. There's different concepts within the runtime that we've talked about. We've talked about workers and we've talked about tasks. And one of the first things that throws people off is that you build something out and you've deployed your configuration. It says, yes, I've got the configuration and things are running, but I've got no data. Why is there no data flowing between my source and my target? And you go along to Kafka Connect and you say, I'm going to use the REST API to say, what's the status of this connector? And it says the status is running. And you think, well, where is my data? If you drill down within the status, you find that each task has its own status. And if the task is failed, if all the tasks are failed, you're not going to get any data. So you have this concept of like it's logically running, but in practice, the connector isn't running. If all the tasks are failed, you're not going to get any data. So to then troubleshoot it further, a lot of the time you're going to end up going down either into the log itself, or you can also use the REST API to pull out some of the status information and get the stack trace that way. But if you don't get to it straight off the bat, so like the example we've got here, it's actually showing what the problem is, and we've got that through the REST API. A lot of the time though, we end up going down into the log. Where you get the log from depends on how you've deployed Kafka Connect. Did you deploy it using the Confluent CLI? Is it using Docker? Is it just on bare metal? One of the really useful things that was added in Apache Kafka recently was dynamic log levels. So if you've got a Kafka Connect worker running, and you're having problems with a connector, you're not quite sure what's going on, you can actually change the log levels dynamically as it's running and also targeting specific loggers. So if you set all the logging to debug or trace, you just end up with screenfuls of stuff that you can't find anything in. It's like a full load of haystacks with no needles to be found. But you can say, well, I'm interested in this particular logger, like just for a particular connector, just for particular connectors, specific operations, and you can set those up to debug or trace, which makes it really much easier to find out what's going on. Now, sometimes the connectors go wrong and you need to go and troubleshoot them like this. Sometimes though, you end up with kind of like logical problems in what you've built. So Kafka Connect supports the ability to do error handling when it hits messages that it wasn't expecting, and also to write messages out to a separate area if they've hit a problem. So a dead letter queue is what we'd call it. Here's an example of how you would use that. So a very, very common error that people have with Kafka Connect is unknown magic byte, which sounds fun, but I promise you it isn't. The TLDR, too long didn't read, of this particular error is that you're trying to deserialize data using the Avro converter, and the data it's reading is not Avro. That's what that magic byte thing's referring to, the Avro kind of like wire protocol. But let's look at this in a bit more detail. So let's say we've got a topic on Kafka and the messages are in JSON. We've written them using the JSON converter, and then we set up our sync connector to read them from the topic using the Avro converter. It's like, well, you can't do that. You can't read JSON using the Avro converter. It'll throw that specific error there. It just doesn't make sense. So the solution here would be to say, well, we'll just use the JSON converter for the sync, and then it works as it should do. What about though, if you think, well, I'm supposed to be using Avro, and I've set up my Avro sync converter, I'm writing Avro messages to the topic it's reading from, I'm still getting this error. A lot of the time, particularly when people are starting out with a Kafka Connect pipeline, they'll inadvertently write non-Avro data to that topic. They'll be like trying out a particular configuration and writing a bit of JSON to that topic, trying out another bit of configuration, writing some Avro, trying something else out, and you end up with a bit more JSON on the topic. So the topic ends up with a mishmash of things. And if that Avro converter reads a message that's not Avro, it's just going to stop. So let's look at the different behaviors that we've got within Kafka Connect for handling this. So by default, Kafka Connect will fail fast. It'll hit a message. If it has a problem with that message, it'll say, nope, I'm done. I'm tapping out. I can't process it. We stop. Which sometimes is very useful if you want to make sure that you're not having any data going through which you really shouldn't be there. Sometimes, though, you just want the damn thing to work. So you say, well, if I hit an error, we've got this errors tolerance setting. Errors tolerance equals all. If you hit an error, screw it, we don't care. Just let it be. Which in itself means that things keep on flowing, but perhaps that's not a great way to do things, just ignore errors as they happen, because they could be indicative of a real problem somewhere, like you've got duff data coming through that you're completely unaware of. So a much better approach is to say, well, if you hit an error, don't stop, because we want the rest of the good data to keep flowing through, but write that bad message or bad messages to a separate topic called a dead letter queue. So that dead letter queue has now got, in our example here, JSON messages on it. We're reading through, we're reading Avro messages, this is all good. We hit a JSON one, we don't stop, but we write that JSON message out to the dead letter queue, and then we carry on processing. We can then take that dead letter queue, which is just a Kafka topic, and we can say we're going to process it using our sync connector, but we use the JSON converter this time. So now we can read JSON and Avro from that source topic. First off, we try and deserialize it as Avro. If it fails, we write it out to a new topic, the dead letter queue, which we just process as a source topic with our sync connector. And we say we'll use the JSON converter this time, and we try and process them that way. There's a bunch of monitoring that you can get out of Kafka Connect. You can use the REST API to go and check on the status of connectors. You can also use Confluent Control Center, or Confluent Cloud's got a web interface to look at the rate of throughput that you're getting on things, to look at the lag that you've got on different topics as they're being consumed by Kafka Connect. There's also JMX metrics that are exposed, so you can get a bunch of low-level information here. You can do things like, we're using a dead letter queue, we're not expecting messages on the dead letter queue, so let's look at the JMX counter for dead letter queue, and if we see the rate going above a certain threshold, we can start to sound sirens and page people and say, well, maybe there's something broken with our pipeline. So there's different monitoring available with Kafka Connect. So hopefully you found that useful, hopefully you found it informative. Kafka Connect is part of Apache Kafka. It lets you do streaming integration between source systems and target systems. You go to Confluent Hub to download the connector plugins and converters. You get connector plugins from the community, from vendors, from all sorts of places. It lets you integrate with all of these technologies that you want to stream into Kafka and out of Kafka. To learn more about Kafka and Kafka Connect and Kafka Streams and KSQLDB and all sorts of stuff in the Kafka ecosystem, head over to developer.confluent.io. And if you have any questions and want to join in the community, head over to our Slack community group. There's thousands of people there. It's a very warm and welcoming place, and I hope to see you over there soon. Thank you very much for your time. Good evening, everyone. Nice to see you all here. I'm so impressed by the turnout. My name's Robin. I work for Confluent. So Confluent, not Confluence. We're nothing to do with wikis, but we're lots to do with Apache Kafka. So Confluent, one of the companies, contribute to the open source Apache Kafka project. We have our own distribution called Confluent Platform and our own managed service called Confluent Cloud. So out of interest, who's using Kafka today? Like day in, day out, I do Kafka. And who's never ever used it? Okay, and who's kind of like tinkered around with it a little bit, but not much more than that? Okay, good stuff. So this evening, I'm going to talk about something called KSQLDB. It's part of Confluent Platform. I'm not going to go into Kafka in detail itself. So there's a great talk before me about Kafka Streams. I will talk briefly about what Kafka is itself, but quite a lot of you know it, and there's a ton of good resources online if you want to learn more about Kafka. So people who know Kafka will know that it's a distributed commit log. If you don't know Kafka, welcome to Kafka. It's based around this commit log. It's an append-only, immutable event log. So you produce events to it, and you can consume them off it, but you can't go back and change stuff. It's immutable. And it's distributed, which makes it highly scalable, and you can partition your data for scale and throughput and so on. And that's Kafka in a very small nutshell. But there's a lot more to Kafka than just a distributed commit log. You've got the APIs around it, like the producers and consumers. You've got the integration API with Kafka Connect. And you've got a stream processing API, Kafka Streams, which you heard about previously. So that makes up Apache Kafka. And Kafka itself is an event streaming platform. It's not just a little message bus. It's not like a message broker. It's not kind of like a way to pipe data from like here over into there. Kafka lets you process your data as it passes through. It has built-in integration capabilities. You can do a lot more with Kafka than just kind of like use it as a dumb broker. And the reason you might want to do that is that the data that we work with in Kafka, a lot of the time we need to do things with it. Very rarely does data happen, and then we're done. Okay, sometimes we just want to collect stuff and like chuck it into a black hole that we'll maybe call a data lake or something like that, but most of the time there'll be things we want to do with the data. We want to enrich it, we want to transform it, we want to drive applications from it, we want to analyze it, we want to do stuff to that data. And the data that we're working with in Kafka is events. And events are all around us. Most of the data that we work with in our organization are events. They're human-generated events, like customers phoning up and customers buying things. They're machine-generated events, like in a factory, you've got like sensors on all the devices. In a network, you've got the firewall, you've got your syslog. All this data around us is events. And so we can use Kafka as our platform through which events flow, and we can process them. And there's a reason why you might want to do that in Kafka. Because when you consume data in Kafka, it's not deleted. Kafka is not like a transient like message bus and like you read something, you subscribe, and it's gone. With Kafka, you produce an event to it, and it's stored in Kafka until you tell Kafka, okay, I'm done with that. Whether that's based on time or size, or indeed you can store data in Kafka forever if you want to. You can set like the retention super high. You can also use something called compacted topics. But it means that you can process the data and use the data in different ways. So think about a factory. You've got this kind of pretty common data. You've got information about sensors. You've got a timestamp, and you've got some readings. It's a factory that produces widgets. And we want to know, well, what did the widget weigh, and what was the temperature at the time that we produced it, and which machine did it come from, and what time was it? With that data, we can do a bunch of stuff. So we can do things like, well, let's set an alert. If a widget gets produced and the weight is kind of like outside the threshold, we want to know about that. So we need to process that data as it's occurring. I guess we could kind of like process it afterwards and say like, oh yeah, by the way, last week we produced like 10 million useless widgets. Or wait until next month when people start phoning up and returning things, saying like, well, that was not much use. But by analysing the events as they happen, you can start to pick up these things. But you also want to know, well, what's happening in the factory? How many widgets have we produced this hour? Broken down by production line, what's going on, and like just looking at those numbers. And people want the dashboards, they can see what's going on operationally. Or maybe we want to take it a little step higher, we want to aggregate and see what's going on, what's the temperature across different types of sensors, and maybe we want to say, well, that temperature, if it goes above a certain threshold, we've got a problem with that. And then we also want to use that data, and we're going to put it downstream somewhere. We're going to put it downstream for ad hoc analytics, we're going to put it downstream and use it to train machine learning models. But the data starts off as these events. And sometimes we want to process them straight away, and sometimes we want to process them later, but they start at the same place. So these events that we're going to process, we're going to use stream processing on it. So using the idea of widgets, we've got red widgets and we've got yellow widgets, and these happen over time. Okay, it's an unbounded stream. Maybe the factory kind of like shuts down overnight, but increasingly unlikely nowadays. But streams are unbounded. Events are continuous. It doesn't mean they have to be super fast. We're not talking about like, it's got to be big and fast data for this to be applicable. We're talking about events which happen, okay? I went to the airport and then I got on the aeroplane and I can't go back and change that. I can maybe wish I did if it was a crappy flight, but these things are sequential, they're append only, and they keep on happening. So it's an unbounded stream of events. And we want to process that stream of events. We want to say, well, of these widgets that we're producing, we've got red widgets, yellow widgets, and then we'd like to pick out a separate stream just of red widgets. So this is like the most simple example of processing a stream. Some stuff happens, and a dependent application or something else is only interested in a subset of those events. So as they're happening, we can say, well, let's filter those down and just pick out a new stream. We've got an application that wants to subscribe to that stream because it needs to know when a red widget happens, it's not interested in yellow widgets. So we can do that. We can use Kafka streams. We can write ourselves some Java code, we can bring it into our application and start filtering the data that way. And that's great. And lots of people do that. It was a great talk earlier about that. Lots of people use Kafka streams. It's part of Apache Kafka, it's a Java library. It's really cool. It's built on Apache Kafka, so it's distributed, it's scalable. You can lose a node, the work will carry on elsewhere, it will scale out, and so on. Hands up who doesn't code Java. Come on, there must, okay, a few of you. So, room of Java people, brilliant. Kafka streams may well be your go-to, and I'm going to talk about the difference later on. But not everyone codes Java. Maybe you do, but do all the other people in your organization or your customers do? Because a lot more people code in SQL. So what KSQLDB lets you do is use SQL to express the transformations and the processing that you want to do on streams of data. And KSQLDB is built on top of Kafka streams. So everything that you can do in Kafka streams, you can do in KSQLDB. But if you don't code Java, or perhaps if you don't want to code in Java, because this may actually be simpler, you can use SQL to express what you want to do to the streams of data. Because SQL is a very, very powerful and expressive language. It's a declarative language. So if we think about the data and those use cases that we had for it, well, we want to know about the widgets. Okay, if a widget goes over a certain weight, well, we want to say, well, select everything from the inbound stream where the weight is greater than a certain amount. That's a SQL statement. We want to know how many widgets we've produced by production line. Well, that's a SQL statement. Group by this. And that group by there, it could be across everything. It could be broken down by time window as well. We want to analyze it a bit more. We want to build an aggregate and have a predicate on that aggregate. Across all of the different sensors, what was the average temperature? And tell me if it went above 20. So you can use SQL to do these things. So you can process the data as it's arriving. You can build up stateful aggregates using SQL. But you don't always want to process the data straight away. Sometimes you want to put it somewhere else. So within KSQLDB, you can actually say, let's take this stream of data and we'll go and put it over there. We'll write a connector and we'll go and put it into Elasticsearch. Or write a connector and we'll go and put it into HDFS or S3 or a database or any number of places. So KSQLDB has this ability to integrate with other systems as well, both pulling data in and pushing data out like you see there. So KSQLDB is this event streaming database. Hands up who's actually used KSQL or KSQLDB? A couple. Come on, hands up. Yeah, a few of you. So some of you used it. So I mentioned then KSQL or KSQLDB. If you've never heard of KSQL, almost forget that I said it, because it's like it's a naming thing. Naming things is difficult. KSQLDB is the evolution of KSQL, and the DB bit on the end and the kind of like the database icon behind it is kind of important, because it signifies what the idea and the rationale behind KSQLDB is. It's not just about stream processing and doing stream processing ETL and kind of like take this and transform it and write it there. It does do that, and it does it very well. But KSQLDB builds on this idea of we have an immutable event log, and these events are built up over time, and we can take those events and we can replay them to give us state. And that state we can query from KSQLDB. So instead of saying we're going to have our events over time and we need to query the state, we'll have to write it somewhere else for our application to query. In KSQLDB, it can actually act as a DB, as a database, and our applications can query that state directly. So that's kind of why it's called KSQLDB now rather than just KSQL. So the principle, kind of like from a very high level view, you have a stream of data in Kafka. KSQLDB is about Kafka. You've got your messages in Kafka, we consume the messages from Kafka, and we can process them. We can write some SQL which defines how we want to process that data, and the output of that is a Kafka topic. So we read from a Kafka topic, we write back to a Kafka topic. and we could process it some more. We can daisy chain our processing. Maybe we don't want to optimize too early our pipeline. We want to kind of cleanse the data and write it back because someone else might want to use that cleansed data, and then we aggregate it or we build a different aggregate. So you can daisy chain your statements like that. Maybe we want to take the data and shove it downstream for analytics. So we take the data, we cleanse it, we maybe aggregate it, and then it goes downstream for our ad hoc analytics. Maybe we want to drive applications from it. If we've got our widget stream with red widgets and yellow widgets, we've got an application that needs to be triggered by a red widget. Instead of our application subscribing to that source stream, and it has responsibility for doing that filtering as well, all our application has to do is says, well, you tell me when a red widget happened, and I'll process it. So you can build that stream processor ahead of time and say, well, this is just going to write out red widgets to here, which then triggers the events in that application. But it's not just about taking topics and writing them back. It's also about our applications down here being able to say, well, hi, you're a database. You've got DB on the end, you're a database. I'd like to know, I'd like to query the state. So you can say, well, we've got an inbound stream of events, and it's to do with like transactions against an account, and we've got credits, and we've got debits. We can materialize that state. We can do a sum against the amount grouped by account. And within KSQLDB, driven by the events coming from a Kafka topic, we can materialize and store that state. It's a stateful aggregation, which means that our application can then say, I'd like to do a lookup, a key value lookup. For this particular key, for account ID 42, I'd like to know what the state is. What's the current value? And KSQLDB will say, the current value is this. So instead of our application having to go out somewhere else for its state, that state can come from KSQLDB. So I'd like to show you a demo. The demo is online. All you need is Docker and Docker Compose, and you can try it all out yourselves. The script's there as well. After the demo, I'll talk a bit more about the kind of things you can do with KSQLDB, and then we'll dig into the architecture, and we'll have a little bit of a peek under the covers. But this is an introductory talk. This is not a kind of like, let's dig down into the bits and bytes of it. So I'll do a little bit of that, but not a whole bunch of it. And then we'll do lots and lots of questions at the end. So let me switch screens and have a quick drink. Okay, normally I have to ask, can you read the text at the back? But this projector is awesome, so I presume you can see it. If you can't, there are seats at the front. So like I say, the script for this is online if you want to try it out yourselves. I'm using it to save copy and paste errors, which is always embarrassing in a live demo. The first thing I'm going to do is I'm going to create a stream. So in KSQLDB, we have this concept of streams and also tables. And I'll talk about tables a little bit later on. But in KSQLDB, a stream is pretty much like a Kafka topic, except we've got schema. Schemas are super important. If you've listened to other talks that I've done, I always rant about schemas and their importance. I'm not going to do that too much here, but schemas are important because schemas let us work with sources of data instead of having to kind of like pass around a whole bunch of files before we can actually use that data. So we're going to define the schema on the data, and the stream that we're going to create is going. Do I need to move the screen, the window up? I can see lots of people doing this. If I do that, is that? If I do that, is that okay? Better? Awesome. So it's going to be a stream, and it's going to capture people's movements. It's super creepy. We're going to track people and where they're at. And we've got three fields. We've got the timestamp, when was the reading. We've got the key, which is who's the person who we're tracking. And then we've got the location. So Kafka messages are key value bytes, okay? And also, they have a timestamp. So we're going to take advantage of the fact that we've got the metadata within the message for a timestamp. We've got the key within the message that we're going to use for the person. So the only actual value that we need to store here is one, which is just the location. I could have a bunch of other fields there. It just so happens the simple schema that I want fits into those three buckets nicely. We're going to use JSON to serialize the data. We could use Avro. We could use CSV if we felt daft. You can also read CSV and JSON and Avro into these. We're going to say we want a single partition because at this point we're creating a topic in Kafka. And the topic we're going to create is called movements. So we say create stream, and now we've created a stream. And I can say show me the streams. And it says here are your streams. You've got one called movements, and it's backed by a topic called movements. And if I say show topics, we can see we've got a topic there called movements. Guys, I don't mean to be rude, but if you want to chat, would you mind? Sorry, just because I can like... Okay, thank you. So, into our topic, we're going to query it. So we've got a stream, and we're going to say select these values from the topic. So we're going to select the row time, which is the Kafka message timestamp. We're going to use a function. We're in SQL, we can use functions, so we're going to cast the row time, which is an epoch big int, and not many people can read those. We're going to put in something a bit more readable. We're going to take the row key and we're going to alias it to person, and we've got the location. So you'll notice this is pretty much SQL. Before someone asks, it's not ANSI compliant SQL, but it's SQL. And I'm doing things like I'm modifying the schema. I'm saying instead of a column called row key, I'd like you to call it person. And instead of this field here, I'd like you to apply a function to it and reformat it and give it a new column name. So the kind of things that you would do in SQL, you can now do to your messages in Kafka. Select this stuff from movements, and there's this thing here called emit changes. I'll explain all about that later. So, show me all the messages in this topic. And it says, well, okay, press Control-C to interrupt me, but there's nothing much yet. Because we've just created the topic, there's no messages in it. So let's create some messages. So we're going to fire up another instance of KSQL. So here I'm using the KSQLDB command line interface. And we're going to do something else, which is nice with KSQLDB. You can insert messages into topics. So instead of using Kafka console, producer, and all that kind of stuff, you can actually do it all within KSQL. So insert into movements Robin, and I'm in York. And now up there we see, okay, that stream has now got data. A message arrived on the Kafka topic. I inserted it using KSQLDB, but it's just a Kafka topic. So it could be whatever producer you're using, whether you're in Java or C++ or Python or the REST API, however you're getting data into Kafka, it's into a Kafka topic, and we can now see that within KSQLDB up here. Let's insert another one. I was in Leeds, and then I flew to, well, I got the train because the flight was cancelled, to Brussels, and then I went to Amsterdam. So all of these things are happening. They've got timestamps associated with them. They've got a key, which is me, and we've got the location. So KSQLDB is showing me the values within the topic, but with a schema applied to it. Now, it's SQL, so we can use predicates. So we can say, select all this stuff from movements where the location is Leeds. And because we're not quite sure if people have put uppercase or lowercase or something in between, we can say, well, let's apply a function to that. Okay, so lowercase location is Leeds. And now it says, well, okay,